welcome to you. Today's topic is electric field lines or lines of force. Define lines of force or electric field lines. That means the path along which a unit positive charge is moved when free to do so in the electric field. Is called the electric field lines or lines of force. Clear? That means the path along which a unit positive charge is moved when free to do so in the electric field is called electric field lines or lines of force. Clear? These lines of force are imaginary lines. These are the imaginary lines. It may be straight or curved. It may be straight or curved. So in which case the lines of force straight, in which case these are curved. In case of an isolated charge, these are straight. In case of combination of two charges, these are curved. Like this. In case of an isolated positive charge, the lines of force are straight and is directed away from it. In case of an isolated positive charge, the lines of force are straight and directed away from it. Clear? An isolated negative charge, the lines of force are also straight. Like this. But in this case, it is directed towards it. In this case, the direction is towards it. Clear? But in case of the combination of two charges, means for plus minus. If these are two very close to each other, then lines of force are curved like this. if these two charges are very close to each other, plus and minus, the lines of force are curved. In this case, the lines of force are curved. So from this, we clear plus minus means two unlike charges. Two unlike charges attract each other. Now, for plus and plus or minus and minus. So plus, plus, very close to each other. In this case, the lines of force are curved. But the lines of force are like this, repelled. Clear? So, in this case, we know the lines of force are curved. So, in case of isolated charge, the lines of force are straight. In case of the combination of two charges, the lines of force are curved. Then, in case of a straight line, lines of force, if lines of force are straight, then we can find out what is the direction of the electric field or intensity. If P is a point. So the direction means the path of unit positive charge. So this is the direction of the electric field or electric field intensity. So in case of curved lines, if the lines of force is curved, then in this case, if we can find out the intensity or electric field at the point P, so for that, draw a tangent. This tangent, the direction of the tangent gives the direction of the electric field or electric field intensity. Clear? Then, in a field, if the lines of force are more, very close to each other, then the field is strong field. The field is strong field, like this. Strong field. If the lines of force are less, not very closed, far apart, like this, weak field. Strong field and weak field. Clear? Then properties. Properties of the lines of force. Now, properties of the lines of force. First, the lines of force are directed away from positive charge and towards negatively charged particle. First point is the lines of force are directed away from the positive charge and towards the negative charge particle. That means the lines of force start on positive, ends on negative. Start on positive, ends on negative, like this. Number 2. Number 2. Tangent at any point on the lines of force. Tangent at any point on the lines of force gives the direction of electric field intensity. Means P is a point on the lines of force. So a tangent drawn. This is the direction of the intensity. This is second point. Properties. A tangent at any point on the lines of force gives the direction of the electric field intensity. Okay. Third point. Two lines of force never cross each other. Two lines of force never cross each other. Explain first. Suppose two lines of force are meet at a point like this. Suppose two lines of force are meet at a point P. So P is a point for both the lines. P is a point for both the lines. Draw two tangent. These two tangent gives the direction of electric field or electric field intensity. So first line U1 is the direction of the electric field intensity. For second E2 is the direction of the electric field intensity. But which is impossible. Why? For one point, it is same point. There is no two direction of intensity. So two lines of force never cross each other. Clear? Fourth point. The number of lines of force per unit area is proportional to the magnitude of the electric field intensity. The number of lines of force per unit area is directly proportional to the magnitude of electric field intensity. Means these are the number of lines of force, this area. So number of lines of force per area, number of lines of force by unit area is directly proportional to the magnitude of electric field intensity. So in this case, the area being normal to the lines of force, area being normal to the lines of force. So what is the magnitude of the intensity? What is the magnitude of the electric field intensity? That means the force by charge. Force F by Q. The charge experienced by the force experienced by the charge. Force by the charge. That is the electric field intensity. So this number lines of force unit area is portion of the magnitude of the electric field intensity. This is the first point. Fifth, the lines of force tend to contract longitudinally. The lines of force tend to contract longitudinally. Means two lines of force means suppose the positive charge and negative charge. Contract longitudinally means these lines of force are curved like this. This is the contract longitudinality. So due to this property, two unlike charges attract each other. So due to this property, attract each other. Number 6. The lines of force tend to exert bilateral pressure. Bilateral pressure, that is sideways. That means plus and plus. Due to this property, two like charges repel each other. Charges repel each other. Your 6th point. 7th point. Find the 7th point. 7th point is the lines of force beat the surface of a spherical conductor. Normally, the lines of force beat the surface of the spherical conductor normally. The lines of force meet the surface of a spherical conductor normally. So this spherical conductor, the lines of force are made the normal, like this. Clear? Number 8. For that point, the lines of force are are first close together in a strong field. Strong field. That means if lines of force are very close to each other, then it is field is strong. Second, the lines of force are far apart in a weak field. In a weak field. That means not closed, weak field. Next. The lines of force are parallel and equispaced. Equispaced in a uniform field. In a uniform field. Close together, strong field. Far, weak field. Parallel and equispaced. That is uniform. Parallel equispaced. That is uniform field. If the lines of force are not parallel in a non-uniform field, non-uniform field, not parallel to each other, the non-uniform, very close to each other, strong field, far apart, that is weak field, parallel, uniform, not parallel, not uniform. This is the point 8. Next point. The lines of force never pass through the conductor. The lines of force never pass through the conductor. The lines of force never pass through the conductor. Because the electric field inside a conductor is zero. Inside a conductor, the electric field is zero. Last point is 1 unit positive charge. 1 unit positive charge gives 4 pi lines of force. 4 pi lines of force. Clear? So these are the properties. First is the lines of force starts from positive, ends on negative. Second, the tangent at any point on the electric lines of force at any point gives the electric field, direction of the field or intensity. Third, two lines of force never cross each other. Fourth, the number of lines of force per unit area is directly proportional to the magnitude of the electric field intensity. Next, the lines of force tends contract longitudinally. Next point is the lines of force tends by exert by lateral pressure. Next, the lines of force meet the surface of the spherical conductor normally. The lines of force are close together in a strong field, far apart in a weak field, parallel equispaced in the uniform field, not parallel in the non-uniform field. Next 9 point is the lines of force never pass through the conductor because the electric field inside the conductor is 0. Last point is 1 unit positive charge gives 4 pi lines of force. That's all. Thank you.